So heading for the construction review on the midterm, what we have on this problem, doesn't have a number, but this problem here, if you look for your packet, I think I skipped or went out of order a little bit, but you'll adjust here. What this is showing is these two positions are the same angle. What it's showing is we copied an angle. Say we copied this angle here. Let me number them so I can talk about them. So this number, say, is angle 1 and that one's angle 2. The construction is demonstrating a copy angle 1 and construct angle 2 with that exact angle. So basically, angle 1 is congruent to angle 2 is what we're using. Now, this positioning with two different intersections, you've got lines cut by a transversal. These are corresponding angles. So, when corresponding angles are congruent, the lines are parallel. In the situation where two lines are cut by a transversal, we know the two lines are parallel. So what we're looking for is one of the choices along that line. Let's see, I don't think perpendicular is being demonstrated, so get rid of that one. Congruent corresponding angles, that looks good. Let's just read the rest to make sure. Alternate interior, those are not alternate interior, but if they were, and they were constructed in a similar way, that would work as well. Alternate exterior, no, it is in fact corresponding. So good. All right, for this one, it is the construction of a perpendicular bisector. Based on the construction marks, what it looks like is they drew a circle centered at B, and it hopefully is the same size circle centered at A. All right, assuming that it is, assuming these are the same size circle, CD is the perpendicular bisector. That's my assumption here of AB. That's a little bit of an assumption. We know for sure, even if they're different size circles, we know that has to happen. Even if you use different size circles, what you're going to get is you're going to get perpendicular. It might not always be the center. It won't be the center if you use different size circles. But this is going to happen. We want which one does not happen. Is AB going to be congruent to CD? Maybe not. That might not happen. So I'm going to probably say no to that, but I don't want to do it just yet. Okay. AE is going to be congruent to EB if, only if these two circle radiuses are the same. So let's say that that is true. CE congruent to DE. Again, if the circles are the same radius, that's going to happen. Actually, it's going to happen no matter what, so that's true. I'm thinking this length AB might be different than that one. Okay? So basically all that's saying is that this triangle here is not isosceles. Okay, these are different. Maybe that's 10 and this is only 8 or something. So that's going to be the one that we look for. All right. Now, constructions review, I don't have on this particular setup, I don't have the ability to complete these with the pen because I can't use the compass tool. At least I haven't figured out yet. So I'm going to go over to Geometer sketchpad and do the best I can with this. So I'll be right back. All right, so I'll have to use this technology. It'll be similar to the compass tool, but you just won't be able to see exactly how I'm moving it. Let's look now at, it wants the perpendicular bisector of AC. Okay, so what we do first is we put the center of our compass tool on A, and And what we're going to do is we're going to decide on a radius to use. So when you use that orange compass, the safety compass that we use, you're just picking a spot to put your pen in the compass. The center of the compass we're going to put on A. Okay? And then that's going to construct a circle. Now I want perpendicular bisector. So the key to this is to pick the same radius. And we're going to center our compass tool over on C. When we construct those two circles, what we get is, we didn't want that. These two circles intersect there and there. If we connect those 2 points, what they represent are points that are the same distance from both A and C, because we used the same radius for those two circles. Okay, so what we're going to do is we're going to construct this line. All the points on this line are the same distance from A as they are from C. That's the whole nature of it, and that's the perpendicular bisector. So that's what your construction will look like. All right, let's see. We want the in-center next on the next problem, and it looks like I can use the same one. All right, so I'll come back. Let's get rid of this. Okay, this one we want the in-center. What we would do for in-center, first, we must know it is the point where all three, the key here is angle bisectors in a triangle intersect. It's called one of the points of concurrency. So, what we have to construct right now, it's basically telling us to construct the angle bisector for 3 of the angles. We actually don't need all 3. We only have to do 2. And then wherever those angle bisectors cross, it's going to be automatic for the other one. So we're going to cheat a little bit. What we want to do with an angle bisector construction is we want to pick a random radius to use. That means just put your pen in one of the spots on the compass. And what we want to do is center our compass on B. We're going to construct a circle. Just imagine you're doing that right now. So your center of your compass tool is here, and you're taking your pen into one of the spots, and you're tracing that circle. Okay, you don't have to do the full circle. What that just did was that located a point on each side of the angle that are the same distance away from the angle, from the vertex actually. Now this is where, I do this a little different than possibly the other teachers. What I do is I actually connect those 2 points. Now, if you look here, what I have is an isosceles triangle. Okay? If I find the middle of this isosceles triangle, it acts as the angle bisector, the perpendicular bisector, the median, everything. So that's my construction explained. So what I'm going to do is I'm going to perpendicular bisect this new segment. I can't do that with A and C because it might miss B. Okay, these might be different distances from B. So here goes. Again, I'm going to pick it. I don't have to use the same radius as what I'm showing you here. So when I show this over here, these are the radii that I'm using to complete my problem. I'm going to make them a little different size. Okay. So I'm going to center my compass tool there, and I'm going to sketch a circle, construct a circle, I should say. Okay, ignore this point. This point has nothing to do with it. All right, and then I'm going to use the same radius, construct a circle on the other end, and wherever those 2 circles cross, if I construct that line with my straight edge, that should be the angle bisector of angle B. All right, I know I'm supposed to leave all my construction marks, and you should, but this is going to get way too crazy. So I'm going to hide some of these just so you could see what I'm doing. Backtrack on the video if you need to see that again. So I'm going to hide my construction marks. Please don't do that because we need to see them. Now this is the angle bisector of B. I know you heard me say perpendicular bisector, but remember, go back and look at the video and see what I really was talking about, because we created a line. This represents the angle bisector of B. Okay, now we got to do that same thing on angle A. Sorry. So I'm going to pick, I could pick any radius I want. Let's go back to this one. This is fine. Hopefully I don't run into this other line at all. I'm going to construct my circle again. The point of that is to get points on the sides of the angle that are the same distance from the vertex. Construct that segment. If we perpendicular bisect this segment, it's going to end up being the angle bisector, because we created an isosceles triangle here. So here goes. I'm going to center my compass tool there and draw a circle with that radius. It can be any radius you want. Oops. Okay. Give me any circle you want. Let me do that over again, because I don't want to run into that other one. Make it a little smaller. All right, I'm going to use that segment's radius centered at that point. A little bigger. The reason I got to go a little bigger is I got to use the same radius on this one, and they've got to cross. Now this is going to get really crazy, but if I connect those circles' intersections with a straight edge, you got another angle bisector. Again, don't erase these construction marks, but it's too messy for me right now, so I'm going to get rid of them. Just hide them. Okay. Right here is going to be the incenter, because it's where two angle bisectors cross. Okay. The third one's automatically going to do that as well. If we wanted to construct that one, we could. Okay. But that's going to be the incenter, is where the three angle bisectors in the triangle intersect. All right, I'll pick up the other ones on the next video.